with Miss B makes it easier, and now moving right along into graphing. This is a series, another series, with just plain old graphing. And once you follow it, you should be able to graph like a boss at the end of the day. So here we have parts of a graph. Well, these are the common parts of a graph. A graph should have an appropriate title. It should have labels on each axis. It should be properly calibrated at intervals of 2, 5, or 10. And it should have points that are properly plotted. Presenting data or results. Graphs are useful for representing or presenting numerical values or results. It is plotted on special paper referred to as a graph paper. Graphs communicate information more effectively than tables because they make it easy to see how the independent x-axis and dependent y-axis variables of an experiment are related. So the table below shows values for the x and y coordinates. Follow the video as your guide and plot all of your points on graph paper. Use a ruler to connect the points, then name the instrument that is outlined by the graph. So you should see me right about now plotting the graph or explaining what's going on. So we have the graph paper, and like I always tell you, with the graph paper you have to make sure that the little piece, if you have a graph paper like this, you have this little piece, make sure you flip it up. Now we usually look for the coordinates, and for this one you'll see here that for the x, alright, so like I was saying, that we have the graph paper, and with the graph paper you have to make sure that the if you have graph paper like this, make sure the short piece, this ending, is at the top so you don't make any mistakes going up, because you want to use the dark blue lines. Okay, now for this type of graph you have to look, well, for all graphs you have to look at the range. For instance, for this graph, the range for the x coordinates run from 3 to 7, so we could say from 0 to 7. And for the y coordinate, it runs from 2 to 18, so therefore 0 to 18. So the y coordinates, or the y line, is longer than the x coordinate line. So we could leave it in portrait. So this is portrait, and this is landscape. So we could leave it in portrait. So let's start plotting. So here we have, so since we're leaving it in portrait, let me turn this way so you could get a better view. You want a better view of the graph. Let's put it up here so you can see everything. Okay. Okay, so a better view of the graph. And so we're going to start off with the x-axis. So the x-axis goes from 0 to 7, and we could do this. We could say 1, 2, 3, 4, 5, 6, 7. So it has enough space. So we go start from 0, and now we have 1, 2, 3, 4, 5, 6, 7. So since that is good, see there, you have to make sure that each of the spaces are equally spaced. So since you have 10 spaces here, you should have 10 spaces here, and then the increment should follow the same. You can't say, oh, 1 and then 3 and then you have here 10. It's not going to be a fluid graph if you do something like that. If you're starting off increments of ones, so you go 1, 2, 3, 4, 5, 6, 7. So that would be good. You can't say 2 Then when you look, you say, as I said, 7, and then you go here and you put 11, and you put another one here, you put 25. It's not going to work like that. The increments must be equally spaced, as in, if you add 1 to this, you get 2. If you add 1 to this, you get 3. You keep adding 1, it's equal going across. Now, for the y coordinate, remember, it goes from 0 to 18. So therefore, let's see if we have 18 spaces here. We can go up in tens, in spaces of 10. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's not enough, so we're going to have to go up in spaces of 5s. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and we're going up to a rounded number, 19, 20. Yay. And so we have our points and see they're equally spaced, and we're going to number it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19, 20. Awesome. And now we label it. So we don't have words for this, so we just put Y. And then down here, we will put X. So X values, and we're going to put Y values. And we could be fancy. Right? And we start to plot. So now how to plot. Here we go. When X is 3, this is here. When X is 3, this is X down here. When X is 3, Y is 2. So, see, X is 3, Y is 2, and you just go across and you put a point right there. Okay? When X is 4, look in. When X is 4, Y is 1. So we do the same thing. Let's meet across here. When X is 3 again, Y is 6. So we're going up here. See that? And so we're doing it each time. When X is 4, Y is 6. So here we have 4 and Y is 6. When X is 1, Y is 18. So we're going right up. And when X is 7, Y is 18. So we're going up and across. See that? Right here. So on it says, use a ruler to connect the points and name the instrument that is outlined by the graph. So we're going to use a ruler, and like I always tell you, always get a ruler that is see-through or transparent, that as we say in sync, it's clear, right? And we're going to connect all the dots that they told us to connect. So we're connecting the dots, and this is what they told us to do. And like I said, you're using a ruler. Use a ruler. Yeah. And then they said, use a ruler to connect the points and name the instrument. So the name of this instrument, if you didn't know, is a funnel. So this is a funnel. So like I said, we had to label our axis. So we have the y-axis, and then we have the x values, and then we named the funnel. We also connected the points as the direction stated, and then we're missing one part, which is the graph title. So we'd write graph. You could write it right here. Graph showing the relationship of the values of y and x to produce a funnel shape. Yeah, you could have anything. You could even write y versus x, but this is a proper title. It's cool. So graph showing the relationship of the values of y and x to produce a funnel shape. And this is what you should get. Okay? Great. Alright, so when plotting, you should use crosses or dots. Using the values in the table, try to plot the following graph. So again, we're going to be plotting a graph, and we're going to find our best fit curve or line. So this graph is a little bit different. It's not about the shape, we're just plotting the same. And so when it comes to plotting graphs, you always have an independent axis and a dependent axis. So the dependent axis goes on the y. The y-axis is the dependent axis, or it has the dependent values, and the x has the independent values. So the dependent values are the ones you're judging. Those are the ones you're judging. And so we're judging the temperature based on the time. Okay? So temperature goes on the y-axis. And so we're going to put temperature, and we look at the range. So the range for temperature is much wider than the range for time. The range for time is only from 0 to 10, while the range for temperature runs from 0 to 100. So here's the temperature, and we put the units. Always put the units if you have units. And then down here we're gonna put the time, and we have the units, which are in minutes. And we could do the time easily. Time, since it's from 0 to 10, we don't have to use intervals of 2, 5, or 10. We could just use intervals of 1. So let's go. So we have here 1. We start from 0, so we have 1. And we have enough space. I think, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, we don't have enough space. We don't have enough space. Okay, so we could do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the graph is going to be a little bit close together. So let's put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so because we don't have enough space for every 10, we do every 5 spaces, see? So that's good. And now for temperature, we are going to go up to 100. So we need to see if we have enough space for this. So let's see. We can be going 5, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, most likely. 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Yeah, we can go up in 5s. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95. 100. So let's just write the numbers in now. So this is increments of 5. If you look at it, each space is equally spaced 5 times. But by 5, because you're not saying 5, 7, 6, 5, 7, 9, 15. No, go up in equal increments. You cannot just start picking points. You see how it has 15, 26, 36. What some children do, they would say, oh, 15, 26, 36, 47. No, you can't do it like that. That's not the way to do it. Your increments must be equally spaced, and then you produce a graph based on that. Otherwise, you're going to get a straight line graph. You will get a straight line graph with incorrect calibration. The calibrations must be equally spaced, okay? So let's continue. 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Hope that you would have already done that. So let's draw the line. In the last graph, I forgot to draw my lines, but just make sure you draw your lines. You could tend to forget because a line is already there. It's best to draw your lines. And then draw your line right here. If you look at it, I'm making sure that I put my arrows. Okay? So if this is 100, then this will be what? Of course, 105, 110, 120, because going up in fives. And we're going to start to plot now. When it is 0, when the time is 0, right, the temperature is 15. So we're going to put 1 here. Okay? When the temperature is 1, when the time is 1 minute, the temperature reaches up to 26. So we know this is 26. How? How do we know? Well, it's pretty easy to figure that one out. Now, to find out what the points in between here equal to, all you would do is minus the small number from the big number. So you say 30 minus 25. So anyway you go, so 30 minus 25 equal 5. You divide it by the number of spaces, so you have 1, 2, 3, 4, 5 spaces. Divide by 5, and you find out that each space is equal to 1. So you just keep adding 1. So it's a 25 plus 1 is 26. 26 plus 1, 27. Understood? You get the same answer if you do 35 and 40. So you say 40 minus 35 equal to 5. And the spaces in between here, it's 5 spaces. So you get the same answer if the calibration is the same, which it should be. And so each point in here would just be 1 as well. Okay? And so let's keep going. So now, when it's 2 minutes, the temperature is 36. Okay? When it's 3 minutes, the temperature is 47. So here we have 47 must be between 45 and 50. So it's a 45, 46, 47. When it is 4 minutes, it is 57. So we have now 6, 56, 57. When it's 5 minutes, the temperature is 67. So 65, 66, 67. When it is 6 minutes, the temperature is 78. So it must be between 75 and 80. So it's 76, 77, 78. When it is at 7 minutes, the temperature is 88. So 85, 86, 87, 88. Right, you see that? 85, and then you count up. And then when it is 8 minutes, the temperature is 98. So you say from 95, and something you could use a ruler too. So 95, and you know here is 8. So it's 95, 96, 97, 98. Right? And then when it is 9, it's at 100. And when it is at 10 minutes, it's at 100. Okay? So this graph is showing you the temperature increase of water. As the table says, you could take exactly the title of the table and make it your graph title. So it says, graph showing the temperature increase of water over a period of 10 minutes. Okay? And so, yeah. And then it tells you find your best fit curve outline. And this looks like a best fit curve. So you can draw your best fit curve to the best of your ability. You could do it freehand, or you may use something called a helix, but you could do it freehand, and that is how you do this. I hope this is how your graph turns out. All right, great. The gradient or slope of a graph can be determined by using values along a straight line. The values may be plugged into the following equation, where you have delta y divided by delta x is equal to y1 minus y2 divided by x1 minus x2. That's how you find the gradient. Now it says, using the values in the table, try to plot the following graph. Give the graph its appropriate labels and title, and determine the gradient or slope of the graph. So here we go again. So this time we're dealing with a table showing the results obtained for how the length of a spring is affected by the force applied to it. So a little graphical. So let's go. So we're going with length is going to be on our y-axis because that is what we are judging. Remember, anything that you're judging is what's going to go on your y-axis. Okay? So we're judging the length. And we know we say length in centimeters, and then we put the force down here. This is what we keep changing. It's dependent. Okay, so force, and force is measured in units of newtons, and we're going to start plotting. So we know for the force, the range is from 0 to 5, right? So therefore, we have enough space. So we could do every 2. 1, 2, 3, 4, 5. You could even do every 3. 1, 2, 3. That's 1 right there. And this is safe because the force is constant in terms it goes every 1. The length is checked every increments of 1. So it's safe. If it wasn't checked in increments of 1, then I wouldn't advise that you do every 15 spaces, right? But this is 5, 10, 15. So let's go 5, 10, 15, 2, 5, 10, 15, 3, 5, 10, 15, 4, 5, 10, 15, 5. Right, so because you don't have any little points in here to determine, like 1.2 or whatever, I would encourage you to do it like this. But if you had 1.2 and all them things and 3.4, I wouldn't have told you to do spacings like this, because then it starts to get complicated, and you don't want to overcomplicate your graph. You want it to be simple to read for your sake, right? And now we're dealing with lengths, and the lengths here are in decimals. Okay, so don't shy away from decimals. They're not that hard. And so The range is from 0 to approximately 8. And we could do every 2 spaces, 1, 2, 3, 4, 5, 6, 7, 8. And you tend to want a large graph. And I think this is large enough. So we start from 0. This is 1, 2, 3, 4, 5, 6, 7, 8. And so we have a number here. 1, 2, 3, 4, 5, 6, 7, 8. And this is good because now you could do your decimals in between here. And how you're going to know what each point is in between there. And remember what I taught you before. All you have to do is minus the little number from the big number. So you said 2 minus 1 equals to 1. And you count the spaces. In between here is 10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you divide by 10. And so each little point in between here is 0.1. So this would be 1.1, 1.2, 1.3, go right up to 1.9, then 2. Right? So we're good. So when it's 0, it's 0. When the force applied is 1, right? Of course, if no force is applied, you won't have any length. The spring wouldn't stretch. And when you apply a force of 1 Newton, the spring stretched by 1.5. So remember, this is 0.1, 0.2, 0.3, 0.4, 0.5, and so 0.5 and 1, right? And so when the force applied is 2, okay, when the force applied is 2, the length of the spring is 3 centimeters. When the force applied is 3, the length of the spring is 4.5 centimeters. When the force applied is 4, the length of the spring is now 6. And look at what we're getting. We're actually getting a straight line graph. And when a force of 5 newtons is applied, you're getting a length of 7.5. So we actually got a straight line graph. If you look at the points, they run in a straight line going from the origin to 0. And that's really cool. You draw a straight line. They actually pass through all the points. Not every time it's going to pass through all the points like that. Sometimes you would have to draw a best fit line, which you're going to probably see in some other video. And draw your lines. And then you draw your line here. So if you're doing this along with me in your classroom setting, at home if you're studying for exams, this should have taken you about 30 minutes. That's why I take my time. I know sometimes my videos are very long, but it's for your benefit. And then we could write the title here. We're going to say graph showing. We're going to take the same title. And my title, if you look at it, is messed up a little bit. So graph showing the results obtained for how the length of a spring is affected by the force applied to it. Okay? If you want, you could also underline your title too. You don't have to, because lines are already there, but if you want to be official, and make sure you follow a line. Find a line to follow. Don't be putting lines in between spaces. Find a line to follow. Be as neat as you can. If you're not a neat person, try your best. Because remember, somebody has to read your work. And so this is the graph I will get. Now it says determine the slope. How you determine the slope? You look for 2 points on the line. don't pick a point you already plotted. In this case, you have 0 here. So we're going to look for a point here. You could sometimes leave out points like 1 point. Don't leave out 6 points. You could leave out 1 point, which is like this point, or another point way up. And you could take as many points as you would have plotted. So you want to make it an average. So I picked this point, and this is going to be my second point. And this is my first point right up here. And why did I name it like that? Because you're going to have y1, and you're going to have x1, and down here you're going to have y2, and you're going to have x2. And I urge you to write it on the graph because you don't want to forget. And so y1, all you're simply doing is looking for the coordinate that corresponds, the y coordinate that corresponds to the point that you picked. And the y coordinate is 8. So it's 8. And the units for the y axis are centimeters. And the x coordinate for this point is, you see what I mean now? So now this is what I was talking about. I told it to plot every 15, and now this coordinate falls in between the every 15 because this point, this will be 1, 2, 3, and then this will be 6. But it's easy. We could find out what that is. So you're going to say 6 minus 5 is 1 divided by 15 spaces. Because remember, there's 15 spaces in between here, which is 0.066667. And so you have 5 spaces across from the 5. So because it's 5 spaces across from the 5, you can multiply by 5 and you get 0.3. You add this number to 5 and you get 5.33. So our number is 5.3 newtons. Okay? And then here we go now. The point here, y1 is 1 centimeter, and x2 is also in between, and we know what it is, 0.06. So it's a 0.06. Well, let's do it again for your sake. Between 0 and 1. So you know that 1 minus 0 equal to 0 divided by 15 spaces is that. And we move in here is 1 is 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we're going to just multiply by 10. And since we're going from 0, you just add 0. And you're going to give you back the same number. So the number here will be 0.67 newtons. Right? So we're doing 2 sig fig. All right, so great. Yay. So now we're going to find the gradient. So the gradient is, you can write gradient, and the gradient is the same as the word slope. And the gradient is a quotient or a division between the values or the differences of y divided by x. And the difference is y1 minus y2 over x1 minus x2. You could also do y2 minus y1 over x2 minus x1. Just now, if you start with 1, you have to start with 1 down here. If you start with 2 here, you have to start with 2 down here. And I'm going to show you that you're going to get the same answer. So let's start with, so equal to y1 is 8 centimeters and y2 is 1 centimeter. And you put it in brackets in your calculator. And then x1 is 5.3 newtons, while x2 is 0.67 newtons, brackets. And then for this one now, you just switch it around. y2 is 1 centimeter and y1 is 8 centimeters. And x2 is 0.67 newtons, while x1 is 5.3 newtons, right? I ran out of paper. So in the event now, we're going to solve, and you just use a calculator. So here we have it clear. We can say 8, brackets 8 minus 1. close bracket, divided by, you have to put your brackets otherwise you don't get the wrong number, open bracket 5.3 minus 0.67, and you get 1.5. 1.5 centimeters over newtons, because centimeters on top, newtons below. And let's try this one. You're gonna get 1 minus 8, and that will give you negative 7, divided by, open brackets, 0.67 minus 5.3, and that will give you a negative number as well. And you end up with a negative divided by a negative will always give you a positive number. And you see, both of them are the same. So just remember, if you're doing your calculations, if you start with 1 on top, you must start with 1 down below. So y1 minus y2 over x1 minus x2. You can't say y1 minus y2 over x2 minus x1. You get the wrong answer, okay? So, yeah, so this is your gradient, and this is your slope or gradient, and it's often represented as m. And you got the same answer, 1.5 centimeters per newtons, right? Or you could write it like this, 1.5 centimeters per newtons. And here I have 1.5 centimeters per newton. So per newtons, anything to negative 1. All right? Great. So the slope of a graph, no matter how large the triangle, how far apart the points, should always be the same. So I forgot to show you that when you're doing make sure you draw your triangle, because they're looking for this side of the triangle. The larger the triangle, the better off you are. Okay? And here we have here 2, 9. So make sure to draw your triangle. Great. Yay. Alright, so for any point on the graph, dividing y by x always gives the same number. Which scientists and mathematicians use the letter m to show that this result, called a quotient, is constant. The whole graph can be represented by one mathematical equation, which is y divided by x equals m. From this equation comes another one, y equals to mx. A straight line graph that passes to 0 represents the mathematical relationship of y equals mx. And that was the graph that we just a while ago did for the showing the results obtained for a spring as a force is added to it. And so this graph is said to be proportionate. If you get a straight line graph that does not pass to 0 but crosses the y-axis instead, it represents the general equation of y equals to mx plus c. M here would represent the slope, and c would represent the point where the line crosses or intercepts the y-axis. And then this graph is said to be, quite frankly, linear. Okay? Alright, so there you have it. I hope this helps you, and we'll just move on into doing more labs. But this time, as we move on with labs, we're going to incorporate graphs. We're going to incorporate graphs in the lab where we're going to have to plot our results to show the relationship between whatever is represented on the y and whatever is represented on the x. Alright, good night. See you later.